Also, we would like to invite everyone to connect with us on our social media accounts, Facebook and LinkedIn. You may follow us and get updated on the latest news and events. For questions or inquiries, you may contact us at sales@infratexenviro.com or through our mobile and telephone numbers. You may also visit www.infratexenviro.com to know more about our products and solutions. Again, we would like to invite everyone to join our last session entitled Jointless Steel Fiber Concrete Solutions, Installation and Maintenance on May 21 at 10 o'clock a.m. Manila time. You may scan the QR code to register or visit our website. Joining us today is Engineer Monikka Tadeo. Engineer Monikka graduated with a degree in civil engineering from the University of the Philippines. She is a licensed civil engineer with extensive experience in concrete reinforcements. Currently, she is a technical business development engineer and been with Infratex since 2019. So that's it for our introduction. I will now turn the time over to our speaker. Hi, Monica.
Hi, Janelle. Thank you for that introduction. I will now share my screen.
Thank you.
Is my screen visible already?
Yes, Monica.
So, good morning, everyone, and welcome to our second webinar. So this presentation is entitled Jointless Steel Fiber Concrete Solutions, Technical Aspects and Design. So just a few background with our company, Infratex Environmental Services Incorporated. Was formed under the flagship of Macafair Group. So we've been together for about 30 years already. We have partnered with Beckart and Payco in giving environmental solutions for in giving environmental solutions. Okay, so just for the quick agenda for this morning, number one would be the types and usage of steel fibers. Number two, the performance of steel fibers. Number three, design and dosage of steel fibers. Features of armor joint, technical data of armor joint, and the benefits of steel fibers and armor joint when combined together. So question and answer portion will be after my presentation. So just a quick review on what we've learned on our first webinar. So steel fibers are your replacement for your rebars and mesh in concrete mix. So in using steel fiber and forced concrete, you can save time and cost in construction of your projects. So normally we use this for distribution centers and warehouses. So we actually have three different types of steel fibers depending on the tensile strength of your project requirement. So first off, I would go to Jamix 3D steel fibers. So with a tensile strength of 1,270 Newton per square millimeter, with a length of this product is Jamix 3D 8060 BG with a length of 60 millimeter and diameter of 0.75 millimeter and an aspect ratio of 80. This can be used for housing, production halls, light traffic warehouses, bulk storages, distribution centers, high bay warehouses, and cold storage rooms. So these are designed for standard floors and hard standings, also used for jointless floors. So based on our experience, we recommend this Jamix 3D steel fibers for the administrative buildings of a warehouses. So we now go to Jamix 4D steel fibers. This one is Jamix 4D 8060 BG. So it has a length of 60 millimeter and diameter of 0.90 millimeter and has a aspect ratio length over diameter of 65. So this steel fiber can be used for scrap yards, food industry, chemical industry, petrochemical industry, underground parking lots, medical and healthcare, semiconductor industry, harbor pavement, and airport pavement. So it can be used for jointless, specifically for jointless floors and for high serviceability pavement. So with this jamming steel fiber, we use it together with our another material, other product, which is what we call the Terra joint, which I will tackle later. So this is used for jointless floor areas, what we call the big bay casting, as I've mentioned in our webinar number 1. Okay, so for the 5D fibers, with a tensile strength of 2,300 Newton per square millimeter, um, with its length of 60 millimeter and the diameter of 0.9 millimeter with an aspect ratio of 65, it can be used for foundation floors with floors on piles. So we normally recommend to use this for seamless floors. Seamless floors are a combination of steel fibers and rebars with continuous pouring. So with no more construction joint and contraction joints, no more sockets also. Okay, so now go to the geometry of a steel fiber. Okay, so as I've said earlier, we have 3 types, 3D, 4D, and 5D, depending on the type of its anchorage and its quality. So from what we are recommending, it will tell the length over diameter ratio or the aspect ratio or the slenderness. So that is it can be 80, 65, 55, or 45. So for the length, this is the distance between the outer ends of the fiber. So it can be of 60, 50, 40, 35 mm, or 30 mm. So also for the finish and the bonding of the fibers. So it can be bright, galvanized, and stainless for the surface. And for the bonding, it can be glued, loose, or bent. So normally we recommend bright and glued steel fibers because it can be easily mixed with concrete by dispersing after adding last to the concrete mix. Okay, so now we go to the characteristics of the Jamix steel fiber reinforced concrete. So number 1, of course, one of its advantages is it increases the toughness. So it shows here that in adding steel fibers to your plain concrete, it will result to a higher ductility. So when adding steel fibers to your concrete, after adding a load, steel fibers will help redistribute the load. So number 2, advantage of steel fibers would have to be increase in impact resistance. So we know that concrete is very brittle, but when you add steel fibers on it, it becomes ductile. So it helps postpone and reduce the crack happening and increase the post-crack stiffness and load carrying capacity. So number 3, it has high performance. So our fibers are high in length over diameter ratio, which is the slenderness. So it would result in a better performance. So the higher the length, the more difficult to pull the fibers out of the concrete. So this shows the picture on the left would be the length of our steel fibers. So the length and how we determine the diameter. So on the picture on the right would be the different types of fibers and its anchorage. So this one shows the tensile curves of the different fibers from 3D, 4D, and 5D. So from the stress strain diagram, as you can see, it shows that the 3 fibers are ductile wires with normal, high, and ultra high tensile strength. It also shows that the 5D is the strongest one because it stretches or expands the most. So thus having the perfect anchorage. So for each type of steel fibers, its pull-out behavior from the concrete mix varies. So as seen on the graph, for 4D and 3D, it shows a similar slip pattern, but for the 4D, it has slip pattern at a substantially higher level. So for the 5D, as you can see on the rightmost picture, the maximum force is utilized with no slip. So next, advantage of using steel fiber reinforced concrete would have to be the resistance for crack formation. So the steel fibers redistribute the stresses within the concrete. So it restrains the mechanism of formation and extension of cracks. So in which, for this case, it can resist arising cracks from temperature and shrinkage stresses. So this would be a sample of our recommended design dosage, from our technical calculation that we give out. So we use a software which calculates these values. So it shows the slab type suitable for your project. It can be of socket floor, jointless floor, or seamless floor. So it also tells you the slab thickness in millimeters, its separation layer, which, for example, in this sample would be a one layer of polyethylene foil. Its maximum joint distance L. For this case, the maximum casting would be 20 meters by 20 meters. So from experience, we've encountered 24 meters up 24 meters by 24 meters. Okay, so for this maximum joint distance, this will not encounter curling up to if you casted 20 meters. Okay, so it also shows the concrete class that will uh, give the client to us. And lastly, the Jamix steel fiber type, which is in this case 4D 6560 BG with its dosage of 20 kilograms per cubic meter. So we give our dosage in a unit of kilogram per cubic meter. So because our Jamix steel fibers comes in 20 kilogram bag. Okay. So the right picture tells the input loads uh, and the loads and locations of the input loads. Sorry. So for these values to be calculated, these are the important parameters that comprises our design. So number one, the uniformly distributed loads. So this is an important parameter that we need from the client. So this one on the left picture shows the input of 40 kilonewton per square meters of uniformly distributed load. So on the picture on the right is the load results for the inputted value. So for a 40 kilonewton square meter of UDL, it results to as seen on the picture, it is 54% capacity. So this value is the capacity to resist stress due to the given load. So when you reach 100%, as you can see on the numbers on the right, based on the percentage, it means that it already reached the maximum capacity it can resist. So the lower the value, the safer it is. So green color means it passes. And then if you're given a red color, for example, for a soil portion, so the SO is the soil, it means that settlement will be expected for the given load. So for this example, 40 kilonewton is still okay for the design. So number two would be axle loads. So we know that most of the traffic from our warehouse or distribution centers came from forklifts. So we normally ask for the wheel loads of these items because this is also crucial because this is one of the problems we encounter for the construction joints. Okay. So another one would be point load. So this is also important, especially when you have high racking system, especially for warehouses that will carry 5 to 6 high racking. So also, we need to know the situation of the soil. We need the CBR value or California bearing ratio in computing the design dosage. So if we need to add some soil improvement or not, or if the soil is already good, then we proceed to the slab design directly. So our recommendations are always supported with technical calculations. So for calculation support, we recommend the most suitable steel fiber type, the optimal dosage, and the best cost performance ratio. So we normally give a cost comparison between using conventional design and steel fiber reinforced concrete design. So whichever would be the most economical, or we also give with samples like 3D options in using 3D and 4D. So whichever is economical, that is where the client will use. So here in the Philippines, the problems we encounter in warehouses are the cracks and unleveled floors. So to achieve that, we recommend to use our Peco armor joint system together with the steel fiber reinforced concrete floor. So here I will show you a video of how Peco armor joint works in the site. Oh, okay, sorry. It's not a video pala. Okay, so now we go to a feature of an armor joint. So this is actually a cut section of a terra joint. So the white part on the center is the cold drawn flat bar with high dimensional tolerance and sharp edges used for top strip to prevent concrete spalling at concrete interface. So for the studs on both sides, this one is inclined at approximately 10 degrees to ensure adequate concrete coverage. So the dowels on the lower right would be of 6 millimeter, 8 millimeter, or 12 millimeter made of high strength steel which provides optimal load transfer between slabs. So on the lower right would be the plastic ABS sleeve for smooth and restraint-free movement of the dowel, which also ensures the good fit of the dowel. So this one is a picture of our armor joint, which we call Terra joint, and the Terra fix that is used for installation. So in constructing a jointless floor, you need these two components to achieve or attain level floors and flat floors. So the picture on the leftmost would be the installation of your armor joints together with the help of your TerraFix. So we will give also a webinar in installation of this armor joint. So stay tuned for our next webinar to see more of the installation of how this is installed. Okay. So why do we need to use stair joints? So you will have to have speed of construction. You will have bigger base at the time. So as I've said earlier, with our experience, based on our experience, we've casted 24 by 24 meters. So that is very big bay and casted one at a time. So you will have no more waiting time for concrete to completely dry. You will have faster finishing and less maintenance in the future. So that is what we are recommending or yes, recommending. You will have less maintenance for your future floors. So you will also have, in using armor joints, this also for providing ARIS protection of slabs to provide minimal movement restraint caused by giant shrinkage and temperature changes of the concrete. It also minimizes the vertical displacement of the adjacent slabs. And lastly, it minimizes the curling of the slab edges because when the forklift passes, load transfer system occurs on our armor joint. So this one is a sample of our armor joint. So the upper picture would be our straight terra joints, which comes in 3-meter lengths with easy to handle sections. So the picture on the lower right would be the X joints and T joints used for intersections for faster construction. We also have curved joint sections used for any curved sections or on the picture on the lower left would be used for loading bays. Okay, so we have different angles like 45 degrees or 90 degrees. We actually depend on what you request. We are open for any request. So this one would be a sample layout of our Terra joint and Terra dowel. So this is a project we've been working, and this is two options we give to clients. So based on their budget. So normally we give a combination of Terra joint and Terra dowels and purely Terra joints. So green lines would be Terra joint and the blue lines would be the Terra dowels. So on the left side, as you can see, the part where Terra joint is placed is maybe the high traffic areas. So we normally suggest or recommend to use the armor joint or our terra joint to put in the high traffic area. So for areas under the racks, we recommend to use terra dowel. So as you can see, it has a racking system on the right portion of the picture, which has the terra dowels on it. So on the right picture would be the layout with terra joint. I think this one is 18 meters by 18 meters. So this one is a sample of a typical recommended design for a loading bay area. So for loading docks, we recommend using combination slabs in using rebars plus steel fibers. So why? Because this is a high risk area, one of the busiest area in a warehouse where cracks are nearly to happen. So this design is actually what we did with our ongoing project in Southern Star in FIT Santo Tomas, Batangas for their loading docks. So we use combi slab for the loading docks, and for the adjacent slab, we only use steel fibers with 3D fibers only. Okay, so this is the actual picture of our um, project in Southern Star. So for the combi slab on the loading dock, we'd have to have the design of combi slab, 25 kilograms per cubic meter of 40 steel fiber with 10 millimeter of rebar, 150 millimeter top and bottom on center both ways. So it has a slab thickness of 190 millimeters. So for the adjacent slab, we only used pure steel fibers with a dosage of 20 kilograms per cubic meter. So this one is the actual picture of their construction on site. And with our ongoing project, and what we also do is actually a cold storage. So this is actually done already, their cold storage area in FIT Santo Tomas, Batangas. They used a combination slab for their cold storage with a dosage of 20 kilograms per cubic meter of 40 steel fibers with 10 millimeter diameter of rebars, 250 millimeter top and bottom on center both ways. So it has a thickness of 200 millimeter slab thickness with a total area of 1,780.74 square meters. So this one is constructed with continuous pouring. So steel fiber reinforced concrete, it helps to achieve optimal resistance to thermal cracking. It also lessens the frequency of maintenance. So they use insulated panels on this cold storage area. They actually have a design. So the combi slab is only for the top slab and before the insulation layer and the bottom slab. So with this, what we are offering is a solution that will require less labor, can save time and save cost, thus having ease of construction. So this is going to be my last slide and a summary of what we've learned with our webinar 1 and our webinar 2 in using steel fiber reinforced concrete and armor joints in a nutshell. Okay, so number 1, the elimination of traditional reinforcement mesh or rebar. So you will have faster and safer construction. You will have no more mistakes of misplacing the rebars or tying mistakes on tying the rebars on site, and no more storage of your big long rebars. And you will have homogeneous distribution in using steel fiber reinforced concrete, having a uniform reinforcement of your concrete structures. So homogeneous distribution, you will have active reinforcement throughout the slab. So all parts would be actively reinforced. So number three, redistribution of stresses. You will have high ductility and increased load bearing capacity, of course, in addition to your concrete. And you will have excellent crack control. You will have significant reduction of concrete cracking and spalling of segments. You will also have optimal resistance against impact and dynamic loads. And using large bay casting, you will have a significant reduction in construction time. So there's no more tying of rebars. So you after mixing of the concrete, you will add the steel fibers last to the concrete mix and direct pulling to the area with the armor joint. So also you will have savings in maintenance cost for future in using a large bay casting, our terra joint. You will also have the best ARIS protection on construction joints. So that ends my presentation. And if you have questions, you can ask me now. Thank you.
Okay, thank you, Monica, for your informative presentation. So I hope everyone learned something valuable on it. So we will now go ahead and take some time for question now. So just a reminder, please be sure to type your questions into the chat box. So we have a first question from Mr. Mark Chua. Can it also be used for suspended slabs?
For now, here in the Philippines, we're not using it for suspended slabs unless it will be used for steel structures. So we're still working on using it for suspended slabs.
Okay, thank you. Another question from Mr. Renz. May I know what type of concrete finish would you recommend for a warehouse with racking system?
Sorry, concrete.
Concrete finish. What would you recommend for a warehouse with racking system?
Oh, can I answer that one for you, Monica?
Yes, sir. Yes, sir.
Yeah, it really depends on the client's requirement. It can be burnish finish or using a dry shake or liquid hardener. Well, most warehouses, some really warehouses are very sensitive in a floor finish because of the dust that it creates also when when the operation is ongoing. It really depends on what type of warehouse is being built. That depends really on the client's requirement or the consultant. I hope that answers your question. Yeah. Some uses polyethylene on top of the floor to make it really a good finish, and depending really on the warehouse, that is being built by the client and being specified by the consultant. I think that I hope I answered your question.
Yes, thank you, Sir Tony. We have a follow-up question from Mr. Renz. May I know if it can be used for column and beams?
For now, we are not into columns and beams. In other countries, I think they have already used that one using steel fibers. Just like in precast construction of like in the segmental concrete panels for railway system, tunnels. They've been using that already in other countries. We've had in Australia, they have been using it also for columns, for foundations. But so far in the Philippines, we haven't started promoting that because of design requirements imposed by the Philippine government and from Philippine standards also that we are a little bit unconstrained. But for other international standards, we still have some already had some confirmation of using it.
Yes, for now, we've been using it only for slab on grade projects.
Specifically for slab and grade.
Yes.
Our mother company, Macaferry, is handling the steel fiber for shotcreting and also for precast panels and for segmental casting also. That would be another topic that we can share with you in the later. In our webinars, yeah. Can you pour a bigger size than 24 by 24? Yes, we can.
Can the rebar reinforcement be reduced significantly with the use of steel fibers? Yes, based on our experience, we only add steel fibers, especially for critical areas like loading docks. But for warehouses with high racking system, we do not add more rebar reinforcement to that. We only use pure steel fibers on that slab.
Yeah. This is where your savings come from. I mean, cost of rebar right now is like 20% high, and depending on the design requirement for the structure, then you have more rebars. Well, the advantage, I think, have been discussed by Monika on the advantage between rebar and the steel fibers.
Yes, thank you, Monica and Sir Tony. Another question from Mr. John. So, do you recommend the use of shrinkage reducing admixtures or SRA when installing jointless concrete floors with metal fibers?
Do you think it's okay adding water to achieve? Okay, so in general, does it mean cost of steel fibers? Okay, can I answer first, Mr. Brixter, Rance? How
Yes, sure.
water cement ratio during mixing of steel fiber? The concrete mix is going stiff rapidly. Do you think it's okay adding water to achieve flowable concrete? Does it not compromise the strength of concrete, especially the shrinkage factor of concrete is high if water added is high? Okay. During our pre-trial mix that we do on site with our engineers, we normally coordinate or we collaborate with the concrete supplier in the batching plant. They will design the concrete mix for the specific structural requirement of the slab on grade, let's say 4,000 psi. So they have a standard for that one. That we don't interfere with that concrete mix. So it's really up to the concrete supplier to design or provide the concrete mix for the particular structural strength. The number 2 question, adding water. If the design of the concrete, as I understand, is only adding water during the batching itself. Adding water at the project site with already the formulated concrete mix is not allowed. You do not add water on site when the concrete mix is already have a higher slump. Okay, so what we do during the trial mix, we make a trial slump test at the batching plant to make sure that on site the slump that is required by the flooring contractor is being achieved. So that is one of the process that Engineer Gilbert will be discussing on our next webinar to make sure that the slump from the batching plant to the site is achievable by the flooring contractor. If it's done in the batching plant, then that's the problem of transporting concrete from batching plant to the project site. So we consider that also during our trial mix. If the steel fiber is mixed on site in the concrete mixer, then that's going to be also acceptable. But water being mixed at the project site is not allowed by, it's not recommended by Beckert. So yes, does it compromise the strength of concrete, especially shrinkage factor of concrete is high if water added is high? Yes, it will do compromise. Next question was, so in general, does it mean cost of steel fibers will be cheaper than cost of rebars for reinforced complete slab? Well, we do a cost comparison for the overall, not only comparing steel fiber with rebar. We do the comparison for the overall cost, considering labor, the reduction of the slab thickness, the cost of construction being the time to finish the project. And number 4 will be at the present condition wherein you need lesser labor. That will be an advantage. Also, it gives a safer construction methodology. Okay, how much bigger than 24 by 24? What's the maximum? In other countries, they have done 50 by 50 actually. The maximum we have done here is, as you said, we've done 24 by 24. We're doing 30 by 30 in one of our projects, but we still cannot disclose which project it is at the moment. But we have already designed a slab of 30 by 30 for our next project if it's been finalized and awarded. Okay. Standard operating procedure Becker, we recommend the base size 30 by 30. More than that could lead to a wide joint opening that can be problematic in the future. Answering to that note also by Gilbert, okay, if the design is really on a really large bay casting, example 30 by 30, that will really depend on the slab thickness. Okay, so the design recommendation is coming from our technical engineers from Beckert. Given all the structural parameters, then we will come up with a design panel or a large bay panel. What we don't want to happen later on is the curling of the slab. It did happen one time already, wherein the contractor did not follow the large bay casting, like 25 by 25. They were in a hurry and they said that we will do 40 by 40. So when they did 40 by 40, maintaining the slab thickness, our design slab thickness for 25 by 25, then the disaster came. The concrete panel curled, meaning it shrank at the middle, and the crack form. So they have to really repair it, like removing all the slab that has been used for Ford and replace it with the required 25 by 25. So that has to be watched during construction time. They have to follow the desired or the recommended slab panel. So overall cost of labor, thickness of slab, rebar cost, steel fibers will be cheaper. Marchua, I would say yes. Especially if you have a really huge area for the slab, you'll have a better savings. For small floor areas like 2,000 square meter, you won't achieve a higher savings on that part. I would say you'll just have to go to a conventional, which 2,000 square meter, like a cold storage, then the advantage there is really beneficial because of maintenance cost. A cold storage, as you know, is very difficult to maintain while it's already in operation. Just imagine you have to uh, stop operating the cold storage and just repair the slab, because where will you then transfer all of your stuff in the cold storage when you maintain the craft?
In addition to the savings that we can get in using steel fiber reinforced concrete, based on our experience with a conventional design of a 200 millimeter slab thickness, with SFRC design, we can reduce it up to 170 millimeters to 180 only. So savings come from the concrete mix.
Yeah.
So as Sir Tony said, the larger the area, the higher the savings that you can get.
Yeah.
So is it possible to do polished concrete finish? I fear that it might hit the steel fibers while polishing it. So based on experience, we use mesh rollers to avoid the sticking of steel fibers for finishing it. So
We haven't had any problems with steel fibers sticking out. That problem has a solution for that one, and Engineer Gilbert will be able to expound later on our next webinar on that one. In all of our projects, during construction, there were, sticking out fibers, but very, very, very minimal. And if it's not properly constructed, then you'll have really big problems. You have to have a very good, reliable flooring contract for this part. Just to take note, though, we do not construct floors. We are only a supplier and a technical advisor and a service provider for our steel fiber and armor joints. We do site inspection, and we do also technical assistance and recommendations for our steel fibers. So one, we do the trial mix, we do a sample washout test initially, and we do site inspection to make sure that the terra joints or the armor joints are installed properly, site conditions are done properly, which is also the responsibility of the contractor itself. So we do guide them, yeah. 30 by 30 is less than 200 cubic meter. What is the work around if we want to pour a bigger slab? Okay, what is the work around if we want to pour a bigger slab? Okay, Depending on your methodology, Sir Andrew Law, uh, it's like a chessboard. Okay. Depending on where you start and where you end. So you can start maybe at the very corner of the warehouse, going out by the concrete pouring. So it's like a checkered board that when it's being laid out for casting panels. So it really depends on the methodology or your plan layout for concrete pouring. So normally the contractor makes a plan layout for the floors before they go into concrete pouring.
For Sir Mark Shua, I have a food plant project which might be interested with your steel fiber. Since this is a new technology as compared to conventional RC slab, you have structural designers who can redesign the slab on field and make a cost comparison so that it can be presented to the owner. Yes, sir, we can give you a recommendation and a cost comparison in using the RC slab versus the SFRC slab. So we just need a few details as I presented earlier, the loads and the soil situation of the project site. So we will send you a floor design sheet that you will be filling out so that we will send this to our technical designer and give you a steel fiber reinforced concrete design.
Yeah, Mr. Chua, that would be a very good project to start with your. We could collaborate with your engineers also for what design you would want for your floor. If you have a Okay, we do collaborate with structural engineers and consultants for the design. Normally, the owners will get a structural designer for their slab on grade. So if the owner recommend to use the steel fibers, then we come in and talk to the structural engineers and make our recommendation. They can compare it with their traditional rebar design and make a comparison. So in that way, you will know how much savings you could generate from conventional design versus a steel fiber reinforced concrete design. Yeah, a food plant project will be a good project also. We're doing right now with the Southern Star, their facilities. It's not only a warehouse, but it's also a facility for their manufacturing firm in the Santo Tomas, Batangas. Yeah. My question is, your food plant is in an economic zone, Mr. Chua? If your food plant project is an economic zone, in a economic zone that will be VAT exempted, so then you can reduce your cost by lesser 12% VAT. This is how we work with Southern Star. They are in an economic zone. So all of our steel fibers are VAT exempted when we sold it to the Southern Star project. Okay. What kind of water reducing admixture do you use in order to maintain workability of the mix? That is being specified by the batching plant or the supplier for concrete. We don't normally recommend what brand or what type of admixture. Andrew Law. So the recommendation is not to pour adjacent slab. Nope, we can pour adjacent slab immediately also. As much as possible, drying time at least of, let's say, in a day, we cast one panel, and the next following day we can already cast the adjacent panel. Sir Andrew, the next webinar presentation of Gilbert will be of help more in details on the sequence and methodology of casting concrete using armor joint in large bay casting. Mr. Mark, if it's not in economic zone, then I'm sorry, but we have to imply the 12% VAT on our material. It's in Imus, Cavite, yeah.
Any more questions? You may type it on the chat box.
We'll be very happy to see you again on the next webinar. Ms. Janelle, maybe we can resend to them again the next webinar.
Yes, sir. I have shared the link for the registration for the session 3. So feel free to register. So yes, we have a follow-up question from Mr. Mark Chua.
Yeah, Sir Mark. Yeah, we'll provide you an effective solution. It's going to be very beneficial and fast to construct, basically. I hope we can work together. We look forward to doing business with you, Mr. Mark. Yeah, Janelle, any more questions? Yeah.
I think we have covered all of the questions. So thank you for all of your questions. If ever you have further questions, you may email us and we'll make sure to assist your queries. So I will send the presentation slide after the session, also the recording. So make sure that you have joined using your complete name for verification purposes. Also, you may fill in the links for the e-certificate request and feedback form. Registration link for the webinar session 3 has also been shared in the chat box. So I think we're good for now. Any more comments, Sir Tony and Engineer Monika?
Yeah, Janelle, can you flash? Monica, can you flash your contact details on the board on the slide so that they will be able to see your number?
Yes, sir. Oh.
Yeah.
So you can email at sales@infratexenviro.com or my email m.tadeo@infratexenviro.com. So I'll chat in the chat box my email address. Thank you.
Yeah.
Okay, so
maybe your contact number also, Monica, just in case they wanted to get in touch with your mobile number.